This week, we'll consider whether welfare or safety net programs lead to major disincentives for work. This concern often looms large in discussions of these programs, the way they are structured, and the levels of political support they receive. To understand the effects of safety net programs on work behavior and hours, we need to use a simple budget constraint framework that you've likely seen in other economics courses. In this case, rather than allocating a budget between two different consumer goods, we'll construct a budget constraint that reflects the trade-off between consumption and leisure. On the vertical axis, we'll measure the amount of consumption goods that are affordable or chosen by a consumer. Think of this as measuring a composite single consumption item whose price is $1 per unit. On the horizontal axis, we'll track hours of leisure the consumer chooses to take, which is simply the total number of hours available in a given period, labeled Lmax, minus chosen hours of work. Hours of work in this setup are determined by the choice of hours of leisure combined with the maximum number of hours available to be allocated to work and leisure. Income will simply be hours of work multiplied by the individual's market wage. One feature makes this budget constraint different than a budget constraint for allocating income between two different consumer goods. Earned income, used to purchase consumer goods, is the direct result of the choice of how much to work. Assume that any individual facing this budget constraint has a given hourly wage rate, and we have everything we need to construct the full budget constraint. To summarize, the model assumes that consumers use all income to purchase consumption goods. The choice of an amount of leisure determines hours of work, and the price of an hour of leisure is simply the hourly wage they give up by choosing not to work that hour. This simple setup gives us 2 points on the relevant budget constraint immediately. First, on the vertical axis, imagine a consumer who spends all of her available time working. This means she will have income equal to her hourly wage rate times the maximum hours available in the day or week, indicated by Lmax. This fixes the vertical intercept and gives the maximum level of goods consumption this consumer can achieve. This intercept is simply equal to the wage, W, multiplied by Lmax. Now consider the opposite extreme case. If the consumer decides to lower consumption of goods to zero, she will be able to reduce work to zero and consume the maximum quantity of leisure hours. This situation describes the intercept of the budget constraint on the horizontal axis. The only thing left now to fully describe this simple budget constraint is to calculate its slope. The two intercepts give us 2 points on the budget constraint. Using these points, we can calculate the vertical change divided by the horizontal change, or the rise over the run. This gives us, after some simplification, a slope equal to the negative of the wage rate. We'll want to be able to use this model to understand how the budget constraint changes with the addition of or changes in safety net programs or other policies. For starters, what if an individual's wage changes? Suppose, for example, that the wage falls from W to a lower wage, W prime. Because W appears in the vertical intercept of the budget constraint, a decrease in the wage must shift this intercept down, as shown here. This shows us that a decrease in the wage results in a flattening of the budget constraint. The budget constraint gives us the set of all possible combinations of consumption and leisure that are possible for one individual. Economic theory also gives us a way to model the exact combination of consumption and leisure that will maximize this consumer's utility. To do this, we'll need to use indifference curves. An indifference curve represents all combinations of consumption and leisure that provide a consumer with the same level of utility. Any consumer will be willing to trade off some amount of one thing for more of another, and indifference curves represent these trade-offs. They are a reflection of individual consumers' preferences. Because individual indifference curves for one consumer represent different levels of utility, they cannot cross one another. Moving from one indifference curve to another in the northeast direction moves a consumer to a higher level of utility. We should think of one consumer as having a whole set of indifference curves, but only some of those curves will be feasible or affordable given the consumer's budget constraint and the amount of earned income they have. Finally, different preferences over consumption and leisure held by different consumers will produce indifference curves with different shapes. Here, for example, we show indifference curves for a different consumer than in the previous slides. Because the budget constraint summarizes the combination of consumption and leisure that are affordable, utility is maximized along an indifference curve that also touches the budget constraint. Because our usual assumptions about consumer preferences mean that indifference curves will have a shape like this that is convex relative to the axis origin, the indifference curve that is both feasible and offers the highest level of utility will be just tangent to the budget constraint, as shown here. Indifference curves lower than this provide less utility, and curves higher than this one are beyond the budget constraint and so not affordable or feasible in this case. Now we have the full model with both budget constraints and indifference curves. Let's see how changing the budget constraint changes the choice of consumption and leisure. Let's see, for example, how does a reduction in the wage affect this choice? The wage reduction is illustrated here by a shift down in the budget constraint with the vertical intercept shifting down. The original utility maximizing point is now outside the new budget constraint and so no longer feasible. It turns out that such a decline in the wage in this case will have two distinct effects on consumers. First, at a lower wage and any positive amount of work, the consumer will have lower total income. With less income, and assuming that both consumption and leisure are normal goods, goods whose consumption rises with income, individuals must reduce consumption and reduce the amount of leisure taken in response to the reduction in income. In addition, in this model, the change in the wage alters the trade-off between consumption and leisure. It changes the effective price of choosing an hour of leisure and giving up the income associated with an hour of work. The lower wage makes it less expensive to gain an hour of leisure, since sacrificing an hour's worth of earnings will require sacrificing consumption of goods. The second effect of a reduced wage will encourage substitution away from consumption and toward more leisure. Thus, the reduced wage will reduce consumption and increase leisure, or reduce work. This is a lot to keep track of, so this chart summarizes the overall effect of a reduction in the wage in this model. Focusing on the effects on leisure, the reduction in effective income leads consumers to reduce leisure, but the change in the trade-off between consumption and leisure leads consumers to increase leisure. This means that overall, the effect of a change in the wage on leisure and work is ambiguous in this simple case. Whether a change in the wage increases or decreases the amount of leisure work chosen depends on the shape of indifference curves and the preferences of individual consumers. Here we see an example of a fall in the wage reducing leisure or increasing work. Here, in contrast, we see the same decline in the wage is associated with an increase in leisure or a reduction in work. At this point, you should be sure you understand this basic model of choice between consumption and leisure. In the next module, we'll model welfare or safety net programs more fully and see that they're a bit more complex than a simple change in the wage. The logic and ways in which budget constraints and preferences interact to determine consumers' choices, however, will remain the same.